The periodic table and periodic trends. The periodic table is an arrangement of elements in which elements are separated into groups based on a set of repeating properties. The periodic table and periodic trends are important to chemistry because based on where an element is on the periodic table, you can predict its properties and how it will react with other elements. The periodic table consists of 7 periods, or horizontal rows, and 16 groups, which are vertical columns except for group 8b. Each element has its own square on the periodic table. At the top is the atomic number. Next is the symbol, followed by the name of the element, and at the bottom is the atomic mass. The atomic number of an element is the number of protons in the nucleus of an atom of that element. The atomic mass of an element is the weighted average of the masses of the isotopes of that element. Isotopes are atoms of the same element that have different atomic masses due to a different number of neutrons. The periodic table is organized in increasing atomic number from left to right. The 2 rows usually shown below belong in rows 6 and 7 between groups 2A and 3B. The periodic table has a line that separates the metals on the left from the non-metals on the right. The periodic table is divided into groups of elements that have similar properties. Group 1A are the alkali metals. Group 2A is the alkaline earth metals. The B section of the periodic table are the transition metals. Next to that are the other metals. On top of the other metals are the metalloids, and on top of that are the nonmetals, including hydrogen. Group 7A is the halogens. Group 8A are the noble gases. Below are the lanthanides and the actinides. Periodic trends. Atomic radius. Atomic radius is 1/2 the distance between the nuclei of 2 atoms of the same element when the 2 atoms are joined. Across a row, left to right, atomic radius decreases. There is an increase in atomic number, which increases the effective nuclear charge. The effective nuclear charge is the positive charge on an electron from the nucleus. There is also a steady number of electron levels. As the effective nuclear charge increases, there is a stronger pull on the electrons and they are held tighter, decreasing the radius. Down a column, atomic radius increases. There is a large increase in the number of electrons, which increases the number of energy levels. More energy levels increases the shielding effect. The shielding effect is when electrons between the nucleus and the outermost electrons shield the outermost electrons from the positive charge of the nucleus. The outermost electrons don't get held as tight as the closer electrons because of this. More energy levels also increases the distance between the nucleus and the outermost energy level, increasing the radius. As you can see in the image, atomic radius decreases to the right and increases down a column. Ionization energy. Ionization energy is the energy required to remove an electron from an atom. The first ionization energy is the energy required to remove the first electron from the outermost energy level of an atom. Across a row, left to right, first ionization energy increases. There is an increase in atomic number, which increases the effective nuclear charge. There is also a steady number of energy levels. As the effective nuclear charge increases, there is a stronger pull on the electrons, increasing the energy needed to remove them. Down a column, first ionization energy decreases. There is an increase in the number of energy levels. More energy levels increases the shielding effect. More energy levels also increases the distance between the nucleus and the outermost energy level. With the outermost electrons so far away and weakly held due to the shielding effect, the energy required to remove them decreases. As you can see in the image, the first ionization energy increases to the right and decreases down a column. Electronegativity. Electronegativity is the ability of an atom of an element to attract electrons when the atom is in a compound. Across a row, left to right, electronegativity increases. There is an increase in atomic number, which increases the effective nuclear charge. There is also a steady number of electron energy levels. As effective nuclear charge increases, there is a stronger pull on the electrons. Since the atom holds its own electrons well, it is easier to attract other electrons. Down a column, electronegativity decreases. There is an increase in the number of energy levels. More energy levels increases the shielding effect. More energy levels also increases the distance between the nucleus and the outermost energy level electrons. With the electrons in the outermost energy level so far away and weakly held due to the shielding effect, the atom can barely hold on to its own electrons. If the atom can barely hold on to its own electrons, it is even harder for it to attract other electrons. As you can see, electronegativity increases to the right and decreases down a column. The noble gases are not included in electronegativity because they have a full octet and do not need to attract extra electrons. Another trend relates atoms to ions. An atom is the smallest particle of an element. A cation is a positively charged ion. A cation is smaller than an atom because it has lost electrons and lost mass. An anion is a negatively charged ion. An anion is larger than an atom because it has gained electrons and gained mass. This image displays common atoms and their ions. As you can see, the cations are smaller than the atoms and the anions are larger than the atoms. Here are some examples for you to try. Pause the video and resume once you have your answers. The answers to number 1 are Mg and At. The answers to number 2 are Si and Br. The answers to number 3 are Cs and Rf. Hopefully this video helped you better understand the periodic table and periodic trends, which are very important to chemistry.